Welcome everybody to another live stream repair. We've got quite a few HomePods in today to get fixed up, so let's jump right into it. First one up is from David, and they've got no power. So let's get that opened up. So we have a small form factor PC that somebody sent in, and its HDMI port seems to be going bad. Where did that go? Here we go. So here's the NUC. NUC is short for next generation unit of computing. It's just pretty much Intel marketing. NUC pretty much just means small form factor PC. And this one here, Eddie sent in, and they're saying that when connected via HDMI, the display will have lines and other issues. So we're led to believe that there's an issue with the HDMI port here. So we're going to attempt to get this fixed up on stream today. At the very least, we'll take a look at it and see what's going on. But first, let's knock out some HomePods here. So let's go ahead and ditch their power cable here. It does look like there's a pretty decent dent in the mesh here from wrapping the cable around it during shipping. I don't advise that you wrap the cable or pack the cable up against the mesh, because then something like this can definitely happen to you. Or maybe it was already there. Who knows? We can probably get that a good massage and make it look mostly normal again. There we go. That's a little better. Alright, enough goofing around. Let's connect this to power. And yes, indeed, we've got no signs of life here. And we see about 4 watts being pulled from the wall. So let's crack this open, and I presume we'll find a shorted diode inside of here, like always. There we go. No, screwdriver down. It's okay, it was going down there anyways. And make sure we get under both of those layers to pry this display off. We want to get this assembly here off in one piece. Just like that. Oh, and that came off wonderfully. No hassle. Yes, reveal your secrets. Time for the pry. Can we get this off now? Not quite. Needs a little more prying. Why you always prying? Why you always prying? Oh my god. Easy peasy. Just checking out the condition of our woofer here while we've got it out. It feels good, nice and smooth. The voice coil through the little window here looks good, and it smells good. Nothing burnt there. All right. Get that power supply out of the way. We don't have any reason to suspect the power supply is the cause of our no power issue here, given that we see 4 to 6 watts being continuously pulled from the wall there. If it was our power supply, most likely the power supply fuse would have been blown, and in that case we wouldn't see any power being drawn at the wall because the circuit would be completely open. In this case, and like many others with no power, the source of this is most likely a shorted diode on the amplifier board, and since the logic board on top gets its power through the amplifier, not straight from the power supply, because there's no direct connection from the power supply straight to the logic board, it goes through the amp first. But anyways, because that fault is on the amplifier, it's preventing enough of the amplifier from powering up and giving the logic board the juice it needs to boot up. So that's why it behaves the way it does. And as to why this diode likes to short out, nobody really knows for sure. Based on my personal experience, all of the HomePods that come in for no power repairs all have one of 2 date codes, 1746K or 1748K. So all the other HomePods that come in for other repairs other than no power, with working diodes still, they all have date codes very older or newer than that. So personally, I think that they've just got a bad batch of diodes in most of these. It's possible that the diode they used for this circuit isn't suitable. It's possible that the part's just cheap in general. But Apple won't talk to us, so we're just left to our best guess here. And our best guess says, based on what we've seen with our own eyes, we've likely got just a bad batch of these diodes here. So let's get up close and personal. And I bet you this diode will be shorted out if it's got 1746 or 1748K on there. And yes, indeed, 1748K. And I bet you if we take our multimeter and put it into continuity test mode, we will see a very unhappy shorted diode. So, let's get our heat turned on, pull that bad boy off, and put a good boy on. Alright, dead diode be gone. Let's grab a fresh new diode out of our parts here. If you want to know the part number that I use for these replacement diodes, or any replacement parts that I use for that matter, I've got all that information on my website at nixfix.com. Under the common issues section, you'll find most of our common repairs and which parts we use to replace those. Boom. Easy peasy. Easy peasy. All right. Let's switch over cameras again. And let's give this board a quick test, see if it powers on now, and also see if it's got any DC offset issues while we've got it here. Alright, let's get all this stuff connected. Alright, before we power this board on, let's get our multimeter connected to the subwoofer so we can see if it's getting any DC pumped into it. And let's give it a shot. Alright, so our no power repair worked. It's now powering up. Let's give it a sec to finish booting here. A good opportunity for us to crack open our Capri Sun here. Very good. Alright, now let's wake this up so we can see if the amplifier produces any DC on the woofer or if we're all good to go. And it looks pretty good. I'm pretty happy with that. Less than 10 millivolts is perfectly ideal. That's pretty much what you want. You can't ask for much better. And no popping whatsoever that I could hear. Not that you can ultimately avoid the popping entirely, but what matters most isn't whether it pops or not. What matters is how much DC is the amplifier actively sending to your woofer. So anything less than 10 millivolts is a perfect score. Anything less than 50 millivolts is still totally acceptable. But once you start growing past 50 millivolts, that's when you can really start noticing the popping. And that's when it can also start causing damage to the subwoofer, to other parts on the amplifier board. And past 300 millivolts, you start reaching, obviously, you start reaching 1 or 2 volts. Anything past that can actually start triggering your death farts. But for him here, for Mr. David, they are free and clear from any DC offset issues, and they've just got their no power that needs to get fixed up. And that's what we got. So let's throw this back together and give it one quick final test, all fully assembled, and we'll move on to the next one. Be stubborn. There we go. Okay, amplifier is back in, power supply is back in, power supply main AC connector is plugged in, and ribbon cable for amplifier to logic board is connected. So let's get the upper parts of our pod put in here. Get that seal for the logic cable put back on. Do not want to forget that and end up with some dirty bass. And now the subwoofer's turn. That's good stuff. All right. Just about done with this guy here. Demi! Welcome to the stream, the guy. Oh yeah, I really do pick like the absolute worst time for streaming for half the world. Okay. Let's give this a quick testy. Drum roll, please. Yeah. This message is held for review. Cease being American immediately. Amazing. Good job, YouTube. Alright, does it have sound?
I'm having trouble connecting to the internet.
Yeah. And volume buttons are lit up nice and even. Got this one all fixed up and ready to go. Set that to the side. And what have we got for number 2 here? Let me in! All right. Number 2. Let's give this a look-see. So this one actually has death farts. So this should power right up. Where's the center of my camera? There we go. Alright, so that's booting up. And I'll bet you a HomePod. As soon as we wake this up after it boots, it'll give us a nice healthy pop. And listen.
I'm having trouble connecting to the...
Oh, punch in the gut. Alright. And then it's going to pop again when I unplug it from power. Oof. That sounds like a couple hundred millivolts of DC on the woofer. Yeah. Let's crack it open and see if we're right. Give it up. Did you know? Fun admin fact. I cannot whistle breathing outwards. I can only whistle breathing inwards. I also can't snap my fingers. I've had dozens of people try to get me to learn how, but they just don't do it. And I hope my kid can snap their fingers. Time for the pry. Time to pry. Yeah. Give it up. Give it. Ah. we incurred a slight casualty there. We may have broken, I think we broke that just grabbing onto it. That's totally my bad. We'll get that replaced. This is why I don't go to the gym. This is why I don't need to go to the gym. I'm just kidding, guys. I go to the gym. Alright, let's take a close look at our subwoofer here. Since it's been popping and farting, we'll want to make sure that this isn't on its way out. And honestly, the voice coil does look a little dull, but it smells fine and it feels fine. So I think we're gonna rock with this. We're gonna rock them with the original woofer here, and of course, you know, if it blows up within the next 6 months, I'll be more than happy to get it sent back in for him and replace that woofer. But as of now, it looks to be in good working order still, despite the unknown amount of DC voltage being pumped straight into it. So we'll find out exactly how much it was getting here in just another minute. This is exactly the problem that we were checking for on the repair that we just did for David. Oh, and actually, I just realized I didn't update the text there. There we go. Absolutely critical. Okay, anyways, as I was saying, what we're fixing on this one is the same thing that we were checking for after we got the last one for no power fixed, which was how much DC is being produced by the amplifier and sent to the subwoofer. So I'm expecting to see a pretty large result here when we get the amp out and powered on. Hey, welcome to the stream, Firmware, and thank you for the kind words. You probably caught it on my website too, but you know, if all they do is just a tiny little pop and nothing else, they work fine otherwise, I wouldn't worry about it. Don't worry about it at all. I've got a couple HomePods myself that have been popping for years now, and they still work perfectly fine. I've also had warranty replacements sent to me from Apple, and fresh out of the box they pop. So I've determined that it's an unavoidable thing to have with these HomePods. What matters is if your popping is also accompanied by other issues like crackling and death farts, or if you notice that the popping is getting really loud. That's a sign that the DC offset is growing past a point of safe. It's growing past a safe amount and requires attention, which is what we're looking at here. We got this one powered on, and as soon as we woke it up, we heard a pretty loud, healthy pop coming from the subwoofer. We could even feel it in the table. And then when we unplugged it from power, it gave us another good loud pop. And also considering Ezra, who sent this pod in here, is telling us that they had death farts with it, all point to those capacitors failing and allowing too much DC through. amplifier is now removed. Let's get a closer look at our board here. Give me just a sec to switch cameras around. There we go. Wi-Fi was giving us some issues, so we got this connected via USB now. So anyways, let's flip this around, and these are the 4 capacitors that we'll be replacing here. But anyways, let's switch back over to the main camera, and let's power this on before we do any repairs and get an idea of exactly how much DC this amplifier is producing. And then we'll have a good idea what exactly we're trying to fix here. All right. You want to make sure you put that cable in properly. If you install it crooked, then you can cause some shorts and you will lose the functionality of both your logic board and amplifier. Don't ask me how I learned. Okay, so we've got everything connected. Let's get our multimeter turned on. That's in DC millivolts mode. And we haven't done anything yet. We've just put these parts together on the bench here so we can get an idea of how much DC offset we're dealing with. So let's get that turned on. And you'll notice, now that it's booted up, the amplifier isn't actually on yet, so we'll need to wake up the amplifier. And goodness. Alright, so we're well past 200 millivolts. Let's jump up to the 2 volt DC scale. Wow. That just gave out on us. So it gave us a good volt. There we go. See how fast that's growing? 900 millivolts now, and it just cut out again. So, that is the goal today, is to get that number reduced from 800 and climbing down to no more than 50 millivolts. And hopefully after all of this, the base will still work. Get the camera switched over again. And one other thing I'm curious about is the date code on our power diode here. Unrelated from our death fart issues, but yeah, so we've got a date code of 1746K on that diode, so despite this not having any power issues at the moment, there's no reason to believe that this diode would last much longer. So we're going to get this power diode replaced while we're in here. But our primary focus and what we'll start with are our 4 capacitors right here. So let's get those pulled off and put new ones on there. Get that power diode replaced, and then we'll give this board another test. Easy peasy. Now, let's get some flux on those pads, and we're going to grab our soldering iron and put some fresh solder onto here before we put new capacitors on. There we go. And grab some fresh caps from the kit. And again, if you're curious which parts I use for my repairs, I've got all the information under the common issues section on my website. Check it out at nixfix.com. I'm quite proud of my knockoff Apple website. A little more flux on there and we'll begin putting new caps on. Alright, that looks pretty freaking good if you ask me. Northridge Fix would say better than factory. I would say looks pretty freaking good to me. Let's just get some of that extra flux cleaned up. Not that it's gonna hurt anything, but might as well make it, remotely presentable in the case someone else opens this in the future. What I would like to get is an ultrasonic board cleaner because I can only get so much of this flux off with Q-tips and rubbing alcohol before. I mean, that's clean. That looks clean in person, but it's quite dirty on camera at the right angle. So, and you also get all these little fibers, which isn't the end of the world, but it's not, you know, not as good as you could get. Alright, and before we forget, let's go ahead and do that preventative maintenance there. Let's get that diode replaced. What's up, Eddie? Thanks for joining the stream. I am quite excited to get to your NUC here after all these HomePods. Nice little change of pace. Won't be the first time I've fixed an HDMI port or anything near, like, you know, just general PC hardware repair like that, but definitely my first time doing it for the channel and for someone else. Yeah. Yeah. Okay. That should be everything this board needs to last for many, many more years to come. Let's give it a chance to cool down here so it doesn't throw off our DC offset measurement too much. Keep in mind, the hotter those capacitors are, the less effective they are at filtering DC. So of course, after, you know, reheating them back on with a hot air gun, they're going to be slightly less effective than they will be after a few days after their break-in here. But as long as we get that final DC offset number on our meter below 50 millivolts, I'll be happy and we'll be good to go. Alright, how's that? Still pretty warm to the touch. Okay. let's power this puppy up and see what we got. All right, time for power. All right, it's powering on. That's good. We didn't, break it by doing the preventative diode replacement or those caps on the back. We'll just give this a sec to boot up and we will get our final DC reading. And the verdict is marvelous. Absolutely wonderful. Far below the 50 millivolt target, and actually far below our 10 millivolt target. Let's just make sure our base still works here. Because that was acting up before we did the repairs here. And Siri's not happy about the lack of... Oh. Yeah, Siri's not too happy. I thought I heard her complaining, so we'll give this one more power cycle here. We'll just make sure that we've got base before we throw this together. Oh, yep, I can feel her talking, so no issues there. Awesome. And we've got very negligible DC offset remaining, so got that taken care of. Let's go ahead and throw this all the way back together and just make sure that everything is still in good working order, and we can move on to our third HomePod repair. Get all our cameras fixed up here. There we go. get that logic cable reconnected down there. Money. Ourselves a fresh basket. No breakage. Hey, take care, Eddie. I'll catch up with you later. Thanks for stopping by. Oh no. Just about ready to put the top on here. I'm just cleaning off one of the sides. It had a little goo on it and it would be a little harder to get to it while it's on there. Alright. Alright, let's check them.
I'm having trouble connecting to the internet. For more info, check the Home app.
Alright. So we got bass, good sound, and the volume buttons are lighting up, and they're lighting up nice and even. So this pod is all fixed up, and I didn't hear any significant popping when we unplugged it from power there. So this one is ready to go. Let's get that set to the side. And we will break out the next HomePod for repair today. Alright, number 3 from Vincent. And they've got no power. Alright. Let's get Vincent's unboxed here. Very nicely packed, sir. Good job. That's slick. We'll see if I can match that when we send it back out. Alright. Here is number 3. And taking a quick gander, we do have a bit of a crack on the top here at the edge, so this is going to be a bit of a challenge to work around. We'll try to peel this off without making that too much worse. That'll be interesting. Alright, but this one has no power, so let's get it plugged in really quick and check if that's true. And yes sirree, 5 watts at the wall, no response. Alright, let's pry this one open and see what we got. And we're going to start away from the cracks, that way we won't hopefully make that worse. Nice. Being careful going around it that second time. And there we go. There's our little crack there. Didn't make it any worse. Now let's get this display off. Making sure we get under both layers for that display. Wow, this one's really hanging on there. There we go. There we go, good enough. Hey, welcome to the stream, Vincent. I don't get bored of it. I definitely... Bored isn't the right word. But I do get, you know, sometimes I do get that sort of, oh, another shorted diode kind of feeling, you know? Sometimes I want a little more excitement in my life. But at the same time, you know, there's those days where you want it to be predictable and you don't want any surprises. So I'll take what I can get where I can get it. I am amassing a pretty decent collection of dead diodes, though. I'll show you guys after I'm done taking this one off. Easy peasy. So let's pull out the dead diode graveyard here. And we'll go ahead and chuck the other ones that we pulled off today into our pile. These are all the dead diodes. These aren't just diodes that, or these don't include all of the diodes that I've just replaced as part of preventative maintenance. These are all purely dead diodes that have come in for specifically no power repair. So we've got quite the collection growing here. And I missed out, I didn't think about it, and the first, you know, couple dozen repairs, I didn't think to keep the old ones, but these are how many that have come in just for no power repair since then, at least. So if that gives you a general idea. And then these are all the caps that I keep from death farts, or death fart repairs. And a couple more over here. And then just random board components that I've pulled off amp boards over the time in an attempt to diagnose and replace various, or repair various issues over the times. And bent screws, you know. Well, there you go. It's the HomePod graveyard over there. Anyways, let's grab our good parts here and get a fresh diode. Looks like we need to order some more soon. I can't say for certain what's going on here. We can only take a guess. You know, Apple hasn't publicly said anything about any of the HomePod problems. So we can't say for certain what's going on. It's possible that they saw all these failures and discontinued them, you know, to try to sweep it all under the rug, get ahead of it. But it's also possible that at the time they were manufacturing these, they legitimately didn't know at the time of any sort of quality control issues with these specific diodes that keep failing. It's also possible that these diodes just aren't suited for the task at hand, but without schematics, it's hard to even, it's hard to even take any guesses here. So we're pretty much left to our own demise as to theorizing what the problem could be here. I'm of the camp of thinking that there's a specific batch of these diodes that are bad, which is why I keep saying diodes with that date code of 1746 or 1748K seem to be the ones that always fail. And then other HomePods that come in for completely unrelated issues that power on just fine have date codes on their diodes that are completely different from the ones that tend to fail very often. So my best guess is a bad batch of those diodes. And of course, it's hard to tell if a batch of a component's going to be bad until they start failing. So gives reason to believe that Apple unknowingly assembled all these HomePods with a large batch of them using this bad batch of diodes. And well, here we are. Until I start seeing HomePods coming in for no power repair with a bad diode that has a date code other than 1746 or 1748K, that's what I'm going to continue believing, is just a bad batch of these diodes. If Apple doesn't release a new HomePod that's at least the same size, if not bigger, and performs at least the same, if not better, I am going to make an open source HomePod. I'm going to take the power supply, the smarts, and the guts out of a HomePod. I'm going to leave the subwoofer and the 7 speakers that they use in there, and I'm going to find an off-the-shelf amplifier that you can cram inside of the HomePod shell. That'll give you, Wi-Fi and Bluetooth capability as well as auxiliary in. That way, if your amplifier inside dies, it's whatever. You spend the $20 to $50 on another amplifier and drop it in, you're good to go. As opposed to all this, all of this extra Apple stuff that Apple's done here. But that's big dreaming. That is big dreaming. I've actually gotten halfway there with one of them. Where is that guy? Ah. There it is. So this HomePod no longer has the original amplifier or power supply. All I did was I took just regular wire, speaker wire, and I connected them to all the tweeters directly. And then I also have a subwoofer, the original subwoofer that sits on top of this and connects to this. And I've actually repurposed the original power port here to be the analog positive and negative speaker input. And so you could use this as just a purely passive speaker. You connect it to like your home theater amplifier or whatever, and you just pump a straight regular audio signal into it. So that was a fun little project. I still need to figure out like crossover filters and properly wiring those speakers together, because right now it's got an incredibly high impedance and I can't turn it up without I can't bump some serious bass through it without putting my amplifier into protect mode. So alright, enough off topic here. Let's get this amplifier put together real fast and we'll see if, of course, it powers on now, and also if it's got any DC offset that we need to take care of. Well, the problem with my current analog HomePod speaker design is all of the speakers are currently wired in parallel to each other. So the resistance of that whole circuit is just way too much for one channel of a home audio amplifier being able to amplify all those speakers. So I got to figure out some better way of doing that than just wiring them all together in parallel and hoping for the best. But it was a good proof of concept, and I gotta be honest, like, even though I couldn't really turn it up that loud, the volume that I did get out of it and the sound that came from it, man, it was really good. Like, it was comparable to all the smart guts that they cram in there and using all that to produce the sound. It was pretty close. So I'm pretty optimistic about that route. Plus, you throw in a third-party amplifier in there that has like Bluetooth and whatever, and now you've unlocked a whole other world of possibilities there. All right. Yeah, we've got power. Yeah, money. Let's wake it up and see if we've got any DC offset. And we're looking pretty chill, honestly. 4 millivolts. I can live with that. Very nice. So no DC offset to be worried about here. Just the vanilla shorted diode. And of course, if my judgment is incorrect and you get your repaired HomePod back, and a few months down the road, it shouldn't, but if it has no power issues again, or if it does indeed start developing loud popping and death fart issues, then that's covered under my warranty. I'll get you a shipping label. You can send it right back in, and we'll get that taken care of for you. And let's go. Hey, thanks for dropping in firmware. Catch you, what's the words? I'm bad at talking. We'll catch you another time. You know what I'm trying to say. Have a good day. If you haven't gathered by now, I'm horrible at saying goodbye. I'm bad at small talk, too. You may not believe it, but I don't even actually like talking. You gotta think of words to say. You get too focused on talking and you start like foaming at the mouth and like drooling. I don't know, that might just be me being autistic. That's not a joke. I'm not trying to make offense or anything. I just legitimately, that's one thing I've noticed is like me and my friends, whenever we like really get like into a certain conversation about something that we're like really interested in, you start losing basic mouth control. It's funny. It's funny nonetheless. I'm allowed to laugh at myself, right? Okay, the amp is fully screwed in. Let's get that logic cable reconnected down there so we don't forget. Wonderful. Yeah. Okay, power supply is in and everything is connected internally. I don't want a pickle. Just wanna ride my motorcycle. Alright. Got that back on there, and without making that crack any worse at all, not too bad. So let's get this plugged into power and make sure it's all ready to go. Drum roll, please. Yeah.
I'm having trouble connecting to the internet. I'm having trouble.
All fixed up. Let's set that to the side. And let's break out our fourth and final repair for HomePods, at least today. Let's see, David, Ezra, and now Vincent are done. And we are now going to take a look at Williams. And then we will finally wrap up with that, with that Intel NUC Mini PC and take a look at Eddie's HDMI issue. But not before. Number 4. I'm going to keep this off camera because they've got their info written all over their box here, so don't want to dox anyone. Go. And they put tape on the box, very nice. Keep that sucker from opening in transit and putting a bunch of marks in your mesh. Just a sec here. And here we go. All right, let's take a look at number 4. And no power, 5 watts at the wall, pretty much what we expect at this point. Let's crack it open and see what's inside. Yeah, it's my pleasure. My pleasure, Vincent. one didn't come up too bad. Woofer check. Feels good. Looks good. Smells good. Smell that speaker. What do we got going on here? What do you got going on? $1,746K. We're not even gonna bother testing it. You know the drill. Into the pile. Okay, let's get this board powered on and see if it's got any DC offset to correct, or if that no power issue was all that's going on. All right, drum roll please. Nice. We got power. Five millivolts of DC offset, perfectly acceptable. Far below 10 millivolts or even that 50 millivolt hopeful target there. Right on. Easy cluster of no power repairs for us today. No DC offset to be seen anywhere. Let's get this thrown back together and we can move on to our NUC repair. Intel Mini PC, next unit of computing, or whatever they call it. let's see what we got. Drum roll, please. Yeah, 4 for 4. Who thought any different? Alright.
I'm having trouble connecting to the internet.
Yeah.
I'm having...
And... yeah. Got everything working on this bad boy. Awesome. Got all 4 HomePods sent in today, fixed up. So we can move on to our bonus round here. Eddie sent in this GMK NUC, or in other words, a small form factor Intel PC. Runs full-blown Windows, and they were saying that they have some display issues using the HDMI port. So we're going to plug this right on in and see if we see the same behavior here. So let's get our text status updated. All right. So how do we want to do this? Well, I've got... where's my closest HDMI monitor here? It's probably going to be that one. And it is bolted to my monitor mount, so let's see here. Let's do this. Let me find an HDMI cable. Here we go. And let's take a little trip on over to my desk. And we're going to switch this phone camera to Wi-Fi, so one sec. There we go. And let's bring you over to my desk, my other desk. Okay. Welcome to other desk. Try to keep things from falling over here. And let's get this NUC connected to some power and video out. Let's see here. There we go. That should give us an image. Oh, we might need to turn this on. There we go. It's turning on now. And there's our boot screen. So I don't see any issues so far. We'll give this a chance to boot up. Let me find a mouse and keyboard for it too. Let's see here. Okay. I've got a wireless keyboard and mouse here. We'll plug that in. And let me pull up my email with Eddie here just to make sure I'm on the same page with their issue. Let's see. When you connect the cable, it's working, but it freezes. You can see the lines on the screen. So, this seems to be working. I'm not going to be able to sign in here. But everything seems to work. I'm just wiggling the cable around and seeing if I can get it to misbehave for us, and it seems to be working just fine. I don't see any damaged pins in the connector. The connector looks fine. We're going to plug the HDMI cable back in. Should be rebooting now. Huh. No problems. Oh, yeah. If I smack the bottom of it, we got some funny business. Interesting. I have a feeling that's not gonna be the HDMI cable, but actually rather, and see, now it's frozen. I have a feeling this is actually a problem with the graphics chip on here and not the HDMI port, because now it's frozen. So let's disconnect this from power. Let's go back over to our bench here. Let's take this apart. See if we don't see any obvious problems inside of here. That's too big. Is that it? Or did they have some more screws under those feet? Looks like they do. 2 more feet, showing up 2 more screws. And we are inside. And there's your SSD there. pretty neat. This is an impressive little PC here. Let's get these off. It's an interesting design. Let's get this SSD off. And then we can get this off. And then we can disconnect these two guys. And this is just USB MSATA card reader audio. Set that to the side. Yeah, here's our HDMI port. And I don't see any issues with the pins on there. Let's take this apart a little further. And there's our CPU, and presumably with integrated graphics. Thermal paste looks fine. Yeah, unfortunately, I don't see any problems with the HDMI port. And after seeing the behavior myself on the monitor there, I'm pretty well convinced that this isn't a port issue, but actually an issue with the actual graphics chip itself. Even though it's integrated as part of the CPU here, it's probably what's going on is, you know, as nifty as this cooling solution is, it probably wasn't adequate enough, and it probably wasn't able to keep the CPU cool enough to start wreaking some havoc on the ball grid array that connects this chip to the board. I've seen this in the past where, like, you know, laptops, it's not so much a thing. At least I'd like to think it's not as much of a common problem anymore, but laptops with dedicated graphics cards used to have this really gnarly problem where the GPU chip would run hot, and the solder balls that they used to connect the chip to the laptop board were not really up for the task, so those solder joints would eventually crack over time from the thermal stress. And that will cause pretty much what we're seeing here with intermittent video issues causing the system to crash and freeze, especially considering it's freezing and locking up. That's pretty much the telltale sign to me that this is in fact a GPU problem and not a connector problem for the HDMI. So that is a little unfortunate, but yeah, there's not a whole lot you can do about that. Considering how weak the integrated graphics on this is, you could probably get yourself like a USB USB video card, like just a cheap $20, $30 USB video card adapter, or just that goes to USB to HDMI or whatever. Those have like little tiny GPUs in them that allow you to sort of bypass your integrated GPU. So that might be one solution for them. In the past, to repair this issue on like laptops, you would just reheat your graphics chip and hopefully remelt those solder joints and get those in good, temporarily good condition again. But considering this is the CPU and GPU, and if we hose it, it's you fry the CPU too. That would make this thing completely useless. I think the best call here will be to use a USB to video adapter if they want to keep using this. So I'll do some digging off stream here just in case this may be an issue that others are aware of and know of a way to fix. But my gut feeling tells me we've got something here that isn't necessarily repairable. So we're gonna call it. We're gonna call that quits for now. And that's about it for this stream. Hope you all guys enjoyed. Not quite a satisfactory result on this NUC here, but not much you can really do about it. Hope you all enjoyed today's live stream repair. And if you have any questions, drop them down in the comments. Shoot me an email. And while you're at it, check out my website, nixfix.com, where I've got all the info you may need on fixing your own HomePod or mailing it in for me to fix for you. With that all said, I'll catch you in the next one.